continuing from where we left off, let's solve the puzzles this way. Must be 1, 2, or 4, 1. And must has different shapes. So this must be a 2. Must be different. But they must also neighbor a different one. So between a 1 and 2, this must be a 4. Between 1 and 4, it's a 2, 1, 2, 1, 2, 1. Let's see. Different shapes. If this is 3, this is 3. So that's impossible. This must be 3 connecting to it. Alright, we're combining rose windows. So you have 2 distinct regions. They must be different. I must extend outwards. I mean, we could block into it, and then we have our shape. But they're the same shape. So you must collect this yellow. Get this blue-green. It's still the same shape. Let's see, can we extend here? We block our own red. Can this red get to this blue? Can, but they still have different shapes. They're the same shape. This is pretty tough. Let's see, we can do this. Let's see, how do we make the region different? Because if it just captures this blue, it just still be the same shape. What's going on here? They must mesh. Each region must have one symbol. It's either in green or blue. Just take this green, but that it's blocked. Why is this? This is much closer. So, can this get this yellow? Is there a method to get this yellow without blocking? So in order to get this yellow, must either take this path, which is impossible. So I must take this path. Which blocks off a red here. So there's a method to getting... This cannot get the opposite red without blocking the path to the other. It's impossible. So this must at least connect to this red somehow. Same with this. This cannot reach this region. This is it. Just had to make room for one space more, huh? I see. Red, yellow isn't a blue. Must have different shape. Red, blue can't be this. Yellow. So this must be connected to. There's only two ways. So this must be this shape. But this can't be the same. Oh, I see. But it doesn't have to be 3, it can be a 4 or much more. So, red, blue. Which red can this get? This one. I must get a yellow. this must be a different shape. Interesting. This red cannot go in there. Must get a yellow. Cannot get a red or this must go up. Blue. Cannot go get another red or yellow. That's given. This cannot be the same shape. This red reaches a blue, which reaches a yellow, but cannot move any further, so it must go down. But how is this a different shape? How can I make this a different shape? Did I just accidentally make a line here? Oh my, there we go. No wonder. I think that solves my issue. Red, blue, yellow. This is different. Okay, looks like a mistake I put in there. Really messed things up. One. Must be at least a 2. Cannot be the same shape. Cannot be the same shape. This go out, cannot be here, cannot connect to this one. This was fine. Must be different shapes. I know they must be different, but how? Can't just combine it and call it a day. This must be different. Oh, this is a 2, not 1. I see. Puzzle. Say 1, 3, 6, 4. Did not expect to see that. How big is this shape? Wow, this is pretty big. Is there a way we can fit a 4 in there? Like this, but then this 3 is real tough. Let's say 3 is like a tooth. I doubt 6 can fit. It's really big. Try and visualize how these shapes fit. It's real tough. How's this 4 positioned? It can be here or here. It's like that. We can put a 6 here. There's no room for a 3. Or 1 for that matter. Let's say... Where's a 6? Problem with this is just entire area has been the shape is too big. And that's a 3, then where's the 6 gonna go? Can I move forward? Can move this? We need space for a 3x3, so this does not work. And this position does not work. This does not work. Let's see, how many spaces do we have? 4 by 6, 24, 25 plus 3 times 6, 18, 25 plus 18, 33, and we have 9 plus 5 plus 12. 14 plus 23. Looks like I'm doing my math wrong. $25, 37. There's 37. Oh, it's 43. I mean, 6 tiles are unused. Six tiles are unused, and what is this? Let's say this goes up by here. 6 tiles are unused. It's 1, 4. It's not work. I see it. It's an interesting puzzle. Oh, it's way hidden there. Plus 3. I don't think there are. Maybe there's more puzzles. Let's continue onwards. Different shapes. If they not shouldn't touch. Looks fine. 1, 2, 1, 2. Well, this could be a 1. So it's 2, then this has to both be 1. 2, then both these have to be 1. So this must be 2. One or a 3. Let's say this is 3. What happens? These all must be 1s. That's impossible. So if this 3, this has to be a 1. So if that's a 1, this must be a 3. But that's impossible. And this is 3, but these have to be 1s. That's impossible. Same for this. And this must be a 3. This cannot extend. This must be like this, so we can have 1s. Cannot expose 2 to one side. So for a 3, could do this. Cannot do this. That could work too. See, this must have a 3. This cannot happen. This could happen. Let's see, we both have 3s here, so let's be orientated like this. 1, 4. 1 and T. Determino. Let's understand what happens. The 3 cannot be exposed. Oh, this makes it impossible. Three can never face, otherwise we must have this. So when placing it, this cannot exist. Either it's here or here. This is I think this is just it. Oh, this must be 3, then V Bentano, 3, V. Must be a V here. Facing 2 has to be 3. Mingle shape. 3. There's a 2 there, so it must have 3's on every angle. Let's think, if this is a 3, then we must have 2. So that cannot face this way. Similarly, this is impossible. So I'll say could have this, but they're touching. So in a shape like this, if it's 3 and 2 at one angle, then this becomes ambiguous, so that cannot happen. So this must happen. So this must have a 2, which must have a 3. This must have a 3. This cannot exist since this will be ambiguous. This is 2, 3. Must connect to a 2, 3, 2. See one in the tower here. Different shapes, 3 and 4s. Looks like they're all orientated away. That you want to connect them. But we know this cannot connect. This 3 cannot be a different 3, so this must be a 3. What shape reaches this spot? This cannot be a 3. It's at least a 1. I see. I want to say I have a 4 here. We could have 4 here, which is... this is fine. So now it's 3, it says at least 1. Extends outward, then this cannot exist. Cannot connect to it. Well, let's see what... Let's do the math here for got 2 by 9, 18, 5 by 3, 6, 9, 11, 55, 73, how many shapes we have? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17 times 3, 51, then 3, 6, 9, 12, 14 times 4, 56, clear doing my math wrong. Oh, I didn't count this. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 times 3, 51. 107? Looks like I'm doing my math wrong. 9 times 2, 18. 11 times 5, 55, 73. Oh, it is 107 because some of them overlap. They're not separate shapes. Okay, that doesn't help. Make this a 3, 4. Okay, so just by quick glance, when a 4 happens, this must be different in this. If it's orientated like this. Otherwise, it comes like this, and that's impossible. So this must be how it's orientated. Is there a similar way for vertical? 4, 3, well, no matter. The only way this can go is like this. So making that a 4. It's not seem plausible. So this is 3, 1, 3. Let's see if I made a correct assumption. If this becomes a 3, in order to be different, you can have 4. That cannot happen. This must happen. This must be a 3. That's different. Similarly, this well, it must be. This is 4. This must not connect to a 3. But that's impossible. Would you look at that 4 there? Let's say this is 4. What happens? This is 3, impossible. Similarly, this is impossible. So these 4 must be extended by this. That's given. Then this 4 is impossible. So I'm making a wrong assumption. These are separate, these must combine. Oh, I just didn't notice the distinction between these two. So, let's say this was 4. What happens? This is impossible. So this must be 4. This, similarly, cannot happen. Because this has to be separate. So this must be combined. Can we do the same logic here? No. We can do this. This can't be a 4 down. This must be a part of a 4 across. Let's say this is 3. This must be 3, which is or down. Let's see. This must be something different than a 3. Same with this. Cannot connect to 3 here. Cannot be down. Well, this cannot be vertical, so this must be these 3. This cannot be a 4 here. Otherwise you have this happen, so this must be 4. Alright, they're getting somewhere. Either this cannot be a 1. It's 2. I feel like 2 is not the best. Alright, let's say this is 3. We have 1 or 2 options. This cannot exist. It cannot. So either it's connected to this, or like this. There's only 1 or 2 options. Then this is forced. Not too sure that's the right. This 4 cannot go down, cannot go left. But if it goes this way, then that's impossible, so it must go up. This 3 cannot connect here, it must go down. This 4 cannot go left. This 3 cannot connect here. What is this 4 doing? Get down, right. This 4 cannot go right. So it must go down. Cannot go left. It must be this. This is our 4. This is not connected to this. Cannot go left. This is our 4. This is our 3. This cannot be a 3. That's a 1. This must go up. Not necessarily. This cannot go left, so this is our 4. This is our 3. I think we broke through the puzzle. Let's see. This cannot be a part of 3. Similarly, it's either connected to this or this. Let's see. 1, 2, 3. Well, this 4 cannot go down. Looks like I found the answer. Cannot go up. This 3 could never connect here. So at least this way. Can never connect here. At least this. This can never connect up, otherwise this becomes there, so this must be here. If these two are different, this must be connected. These two cannot be different, they must be connected. And this cannot connect here. Nice. I quite like that one. That was a nice solve. Real nice solve. Let's continue onwards. Must have different shapes. These two must be the same region. Otherwise, they're these two the same. This cannot connect this way, or this way. This is quite limited. Well, first things first, this cannot go down. Cannot go left. Cannot go down. Could be this. Cannot go up. Well, let's see. Fell here, it's fixed, so can't go down. Can't go left. this is the only shape you can make with this. This cannot connect here or here. That must be it. Must be different, these two. We can just do a square here, be fine, correct? So this must be a 1, a 3, and a 2. 3. A 1, a 3, and a 2. Well, 3s can't touch each other. Can we do 3? This must be different. This has to combine. This cannot be a 2. So this must be 3. Must be different. Let's see. There must be 3s. Bunch of secret puzzles everywhere. Forced. Three cannot connect to this. This does not have many options to go. Cannot go down. Cannot go up. Cannot go here. Let's go here. This L cannot go down. It has to be this way. Cannot connect this way. There's a bunch of secret puzzles. This will continue. must have different shapes. What do we have here? This cannot connect this way. Similar to this. This goes up, this has to be 2, so this must go right. Cannot be 1s, this must be a 3. This cannot go down. Well, it can go down. It's a lot of fixed positions. Like if this is down, this must go this way. Similarly, if this is this, this must go this, otherwise there's a 2. This cannot go down, must go this, and then it's impossible. This must be 2 different ones. So this cannot go left. This must go down. This cannot connect this way. This cannot be left. This becomes impossible. Cannot be down, has to be right. This must be at least 3 then. Let's assume this is this way, this must be here. This must go up, this must go this way, and then this is impossible. Then this region must go up. That's a 3. See, this go left, which is more fixed. This can only go one direction. This goes right. This go down. Right. This makes it 2 region. That's impossible. So this must go up. This must go down. Let's go. Then this makes it 2 region. I think this must be it then. This makes it 2 region. This cannot go this tile, let's go down. Cannot be separate, must be included. Cannot claim any of those tiles. Cannot claim this tile, must be. Cannot claim that tile. Cannot claim either this or this. Must collect this, otherwise impossible. Cannot go here. Cannot go here. Cannot go here, at least. So it includes this. What happens to this one? That's impossible. So it cannot include that. So if it goes here, it's impossible. So it goes here. Nice. These two cannot claim the same tile. This is a 1. Cannot be a 1. It has to be at least 2. This is 2, so this must be 3. This must be 3. Must be connected to 2 or 3, either this or this. These cannot be the same tile. Cannot capture this or this, which makes but if they're the same. Well, no, this cannot happen because it makes a 1. So this is 2. So this has to be 3. Cannot go up right here. Cannot connect this way. Alright, let's cook this hidden puzzle. Oh my. This must be either this, or this, or this. Can be any other shape. Well, let's just take a look at this. This makes it impossible to make that region, so that's no good. Good. So either this one, this, they both share this. Let's imagine it's this. What happened? Where does this P go? It's impossible. So this must be this. And each region has to be at least one, so there's no one region. So I think this must be the play. Does this do? Not be either this or this. Possible. Cannot be this. Cannot be this either. I believe this should be the play, but that cannot be it since that's connected, so that leave this way. Cannot claim this tile. Let's see. This cannot be going that way. This cannot fit. This must go 2 outwards. Collect this one. Must be at least this. But can't be that, so it must be at least P. But it's P there, so this must be W. Well, not W yet, but alright. There's T and P, so this is W. This must be a P. Let's see. This is dangerous. This must be W, since it cannot go down more, but it has to be between these 2 regions. So W exists here, but how? It cannot go this way. It cannot go right, so it must go up. This must be a T. Between a T and W. P. Alright. This has to combine. Otherwise, it doesn't make sense. Then this must be the only shape it can do. Cannot go down, since this is here. So it must go here. This cannot include this piece. Cannot go this way. Must go down. This cannot exist. So it must go down. Cannot include these pieces. Cannot join with these 2. This does not have much room, must be at least 3 in this direction. We have 4, which shape can this be? Cannot go here. Let's go 2. This is impossible. I believe this is the shape. Plus. So it's quite limited where this goes, because an X must contain, it must include a lot of X's. I'm just going to make a quick assumption to this. This must have an X somewhere, so that's not it. Looks like I solved it. I see a hidden one right here. Must be one of these. This is a 2. What shape does this be? Between a 1 and a 2. This must be in either direction. This must be at least a 1. 2. This can only be a 2. Here or here. What can this be? Either a 1 or a 4. This 1, this forces this, the 1. Either 2 or 1. It's 2, this must be a 1. Must be 2. I'm just making a guess that this is the 2x3. It's working out so far. that's 1, this could be 2. Cannot happen. No, this must go down. This has to go down. Let's see, if it's 2 here, this must be 1. This must be 2, which is impossible. 2. Let's extend downwards. 2, 1 doesn't really fit. It's 2, this must be 1. This can only fit 2, which is impossible. 2, 1. Between these 2. Is here 1, which doesn't make sense. 4. It's 2, 1. Doesn't make sense. I think this must be 2, 1. Reach an impossible state. Get me 2. I think I locked into the solution there. Well, this cannot be this. It has to be this. Must be this, which connects it to let's connect to an L. This cannot happen. This must be occupied by 2 L's. If this happens, this is impossible. That's also an impossible state. I believe this should be it. Oh, there's a puzzle right here and here. Must have different shapes. If this connects to here, this is forced to be a 2. So this must include one more. Which one's the most forced to become 2? What does this blue see? Red. So max of this is a 2. Same with this. These are the maximum of this can only be a 2. These cannot combine. This is forced to be 2. This must be 3. It must be 2 or 3. So this must be 3. This is 2 or 3. This is 2. This, no matter what, it has to be 2. So this must be 2. This must be at least 3. This cannot combine with this. Must be at least 3. Two, 3, 4. Must be one of these shapes, Start with what we know. Okay, let's have different shapes. What shape is this reaching? It cannot be 4, it must be an L shape like this. What happens when you do this? This forced to be this, but what does this go? Nowhere. So this has to be here. This blue cannot be an L shape to capture any of these. Could be a 3 though. This blue cannot be a 3. Cannot be an L. It has to be a square. It has to be a 3. Between this must be an L. Where you can get an L shape from here. This must be a 3. Right. I'm not too sure. Because this could be 3 and square. Man, they're quite hidden some these puzzles. I couldn't believe getting this one. Let's continue on. Must have different shapes. What happens here? This must be a 2, which is impossible. So this can never connect. So it's at least 2. 3 or 2, we're not sure. This cannot be 2 different 2s, so it must include a 3. Similarly for this and this. Then this cannot be a region of 2. Must be a 3. Let's see. This must be at least 2. Cannot. So this is 2. This is 3. This is 3. This must be 3. 2. Must be 3. Possible. It's 3, it's 2. Must be 3, this must be 2. If this is 3, but this is 2 though. What's going on here? No matter what, this has to be connected, these two. If they're not connected... Okay, that's cannot be 3. It can be 3. 2 and 3. That's where I messed up here. This is 2. There's no left turn. This is 2. This is 3. No matter what. When connecting the 2, this must be a 3. It must be a 3. But this is a 2. This has to be a 2. These have to be connected. These have to be connected, but does not necessarily have to be a 3. It can just be a 2. Okay. I see now. Force 2. This is 3. This must be 3. Must be at least 3. So we found out that this is a 2. So similarly, that does not have to be a 3. Just found out these just have to be connected. Must be 3, 2. Got 2 and a 3. Between that, must be 4. There must be 2, 4, 3. Must be 2 somewhere. Cannot be 4, must be 3. Cannot go this way, it must be 3. Cannot be 2 separate 2s, this must be 2. This must be 2. This must be a 2. Say this is 2. This is 3. This must be 2. Impossible. So this is 2. Then this must be... Can be 3, but this can't be 3. So it must be square. Can't be a 1, must be part of the 3. Cannot connect. Between a 1 and 3 is a 2. Between 1 and 3 is 3. 2. 2, it's a 3. This must be at least 2. Let's say this is a 3. That's the only position, which is impossible. That's not a 3. So it's 2. Either here or here. It's here, that's impossible, so that's 2. This cannot be 2, it must be 3. This cannot connect to here. A1, this 1, this could be 2. These two cannot combine ever. This is 3. This must be 3. This must be a 9. 1. B1 and 3, this must be 3. Between these two, this must be a 3. This must be a 1. You always think they can fit as 1. It's 1, 3, 3, impossible, this must be a 9. Oh, I just clicked the 6, huh? Alright, so it's forced. This cannot go here or here. The range in this 3 can go is here. Here and here. This one's quite limited. The only option this can ever be is this or this. Nothing between. Similarly, this or this. Once this is defined, then this has to be here. I see, it has a unintended side effect to make the shapes either this rotation or the other. So, this is the most limiting one. Let's see, it's 2, 1. Can this ever be solved? I'm gonna say no. So it's the other position. This cannot go up. Alright. Now this one. About 1, 2. Anything else? 2, 1, 1. Nope. It cannot be a 3. I think this is the only way this can work. Between a 2 and 3, this is a 1. Let's see, 1, 2. This must be 1. I think it's solved now. Oh, gotta be careful. Sweet. This must be at least 2. items. So this cannot be 3, it must be 2. And this must be include a 3, which is this. Now go vertical, it's horizontal. This could be 1, 2, which is impossible, so which must be 3, 2. It's between 2 and 3. 2 and 3 is a 2. Could be down. Say it's 1. It's gonna be 3. Impossible. So this is a 2. Not 2, it's 3. 1, 2. This must be a 2 somewhere. Alright, this is 2. This is forced to be a 4. This is 6 somewhere. Between this 6, this must be 4. 2. 6 somewhere. Means this is a 2. Let's see, 4 or 6 here. This is a 4 or 6, and this is 6. Six is touching this one. So this either is a 4 or a 2. Let me say, why? If this is... Four or 2, huh? Let's see, 2 touches this region, so this is either a 4 or 6. This must be 6, because what's getting this piece? This must be 2, 4. Between 2 and 4 is a 6. Is it 2? This is impossible. Similarly, this is impossible. This has to be where the 2 goes. has to connect to a 4 or 6. It's 4. Well, 4 and 6 exist here, so this must be 2. This must be 4. This can't be a 4, it must be 6. Must be 6. I can do it 2. Alright, I think that's most of the puzzles here. Still not good at finding the secret ones. Pretty sure that's in the other zone. Alright, let's do the... Oh my. Let's work on what we know. These two contain a different shape, then they must not be combined. Let's see. This cannot go down. Alright, what orientations does this F pentamino can use? Let's see. Let's draw it out. Yep, this. And this. Can it capture any of this? I think it has trouble capturing the bottoms of this. Must not. Could be here, here, or here, or here. What else is quite limited? Alright, These cannot be, they must be the same shape. Since these are the same shape, this cannot combine here. Or here. This cannot capture a piece here or here. Similarly, this cannot capture this piece or this piece. This is forced to be this shape. Could be combined. Yeah. Unsure. This cannot capture this piece. Cannot either capture any of these. What orientation is this? Can only be this. Can be either here or here. Where's Z going? Does it have to connect to this? What else can it do? This cannot be part of the 3, because otherwise it will connect to this. Or this. So this must be connected. See, this cannot capture this piece. Similarly, this cannot capture that. So this must extend outwards. So this must be 2, can't be a 3, so it must be 4. But this is a 4. They're the same shape. Let's go through again. Must be at least 2. At least 2. Let's extend outwards because it can't be a 3. It can't be a T shape, so it's an F pentomino. So this must be a 3. Let's see, this must be at least 2. But it can't be a 2, so it must be at least 3. Can't be a 3. Let's see, 4, can't be a 4. It's all forcing moves. W. Can't be an extended W. Right, this is 2. See, just a bunch of puzzle tricks. There's this junction, so this has to cannot connect to each other. This is 2, this is 2. Between 1 and 2, this is at least 3. Can't be 3. Can't be 4. It's 5. solve this. Let's see. Can be a 1, 2, must be 3. Looks like this can only be. It's 5, 4, 5. Alright, this should be solvable. Now we can't extend this way. It's like this that we have. Odd shape, yes. That's 2. Let's see, this cannot get this piece, otherwise it becomes 2. So I must go up, left or right. If this is up, this is down. You have a giant F pentagonal. This cannot capture. It's 3. That's okay. What's the other method we got? That's okay. Ah, because it can't connect here. So it must be here. Sweet. Alright, this shape is quite constrained. Must have 4 long. Either here or here. Must be a length of 4. It can't be like this. It says 3, 5, 3, 5. Must extend. This is the 4. Was 5, so that's okay. This is W. Must go out here. This L must go down. That's complete. Now this shape is an oddity. This cannot capture this because it will make a 1. So this cannot be this. 2, 1, 2, 1. This cannot go down. This must be 2. Now this is solved. 1, 2, 3, 4, 5. This must go down in order to. Oh, I forgot to complete this one. This is complete. This is complete. This cannot be continued, so this must be 4. Alright, pushing through. This cannot capture this, must go down. Honestly, this does not have to be an F pentagonal. This cannot go down, it goes this way. So this must be at least 2, but it can't be 2, it can't be 3. Can combine it with this, which is decent. shape does this can be 3? That's impossible. For this, it's only a vertical line. Somewhere here or here. Since it's either here or here, this must exist. For this to be here. This works. Extend it. C2. This cannot connect here. Alright, 4. Where's this one going, down or up? Oh, this has to go up. Alright, what's not highlighted is complete. Oh, it's F phenomenon. That was real good, real fun. Quite like that one. It's seamless. +4. I bet it's like +5. There's like 5 hidden, super hidden puzzles. I only can find at least 4 so far. That nicely wraps it up. Completed this area and can continue on to the next zone. Looks like 3 different gates you can go through. I think we can work for the left side then. Still much of the game left, so it's nice. Alright, I'll end the video here and we'll be back with the next one.